Hello there, and welcome to a little bit of science with myself, Mike, and this is...
Michael Carter.
Michael Carter, that's right. So we're going to be looking at sound today, Michael, and we're going to explore all about sound. But first, what is sound?
Sound is a thing which people hear.
Yeah.
And it is also in waves.
It is. Waves. Waves are very important with sound. So yes, so sound is something that's all around us. We all use, because we all hear things, and lots of things produce sounds, don't they? Mm-hmm. Yeah. Including us, we produce sounds, don't we?
Yeah.
Yeah. We're looking at sound then. So we produce sound, don't we? We talk. So there's a little experiment we can do. And which will help us understand what sound actually is, because we can't see it. So what I want you to do, Michael, is to raise your hand with your palm flat out. That's it. And then I want you to put it on your chest, right in the centre. That's it, with your flat palm. So touching your chest. Can you feel that? Yep. There we go. Mm-hmm. Right, and you out there can do it too. So what I want you to do is I either want you to talk or hum. I think we should hum. What can you feel through your hands?
Vibrations.
That's right, ladies and gentlemen. It's good vibrations, in the words of the Beach Boys. Yes. And that's what sounds are. They're vibrations.
Queued up early.
Which I should have queued up earlier, and I've just messed up in the rehearsal, so we're not doing it. But anyway, good vibrations. Thanks for telling everyone I've messed up, Mike. I'm a scientist, don't you know? We never make mistakes. Anyway, good vibrations. That's what we're talking about today. Yes? So, sound is vibrations. Vibrations of what, you may ask, Michael? What do you think's vibrating?
Your chest.
Your chest, yeah. And what's inside your chest, inside your lungs? What's inside there that might be vibrating?
Little hairs that come together.
Not quite. Now, hairs do come into hearing, but in terms in your lungs, you've got air, haven't you?
Yeah.
Yeah. And it's the air that's vibrating is how we hear. Yeah? So vibration is the knocking together of bits of stuff. So if we imagine the air is made up of lots of little tiny marbles. Can you imagine that?
Yeah.
Lots of tiny marbles.
There you go.
Yeah. And when you make them move, when you make them vibrate, they bash into each other, and that's the vibration. And that's how it travels. That's how sound travels, by knocking on. And we can demonstrate that, ladies and gentlemen, in a number of different and interesting ways, which is what's going to be the rest of our little segment. Right, so we're going to crack on with our first experiment, Mike. Are you excited? Please say yes. Please say yes. Please say yes.
Right. Yes.
Okay, great, excellent. So, some of you may have seen this or done it before. So, for this experiment, Mr. Carter, we need paper cups, we need string, and we need two important tools. One is a pencil, which I'm going to ask you to hold so I don't lose it. And we also need a pair of scissors. So what we're going to do, ladies and gentlemen, is we're going to make a type of telephone. A telephone, that's right, Michael. A telephone. Now, what do telephones normally need?
There's quite a few things. A line for a start.
A line, yes. And what does the line do?
It catches the sound and then it makes it travel a long distance.
Correct, yes. So what we're doing with the telephone, ladies and gentlemen, is we're taking sound at one end. In this case, the end will be Michael. I should call you that, should I? So he will be our transmitter. He will be producing the sound that we're going to transmit over a distance. Yes? And then I, myself, Mr. Mike Borgia, will be the receiver. And I will be receiving the call from Mr. Michael Carter via the medium of two paper cups. And ladies and gentlemen, you can do this at home. Two paper cups and a bit of string. Can it be done, Michael? What do you think?
Let's hope so.
Let's hope so, otherwise this is all fairly pointless. So, what we're talking about here is how sound travels. Now, sound doesn't just travel through air. Did you know that, Michael?
No.
No. So it's not just through air. So we tend to think of sound just as something you hear with your ears through the air. But actually sound can travel through anything that's made up of stuff, matter, anything that can vibrate, even things that appear solid.
Water even.
Even water. Now, here's a bit of trivia for you. What do you think one of the loudest animals in the world is? What do you think? If you're watching on chat, if you're watching on Facebook, put your answers in the column. What do you think, Michael?
Not a clue.
Not a clue. Well, I'll tell you. It's a whale. Now, you may ask me, why is it a whale? Because whales make sounds in the ocean, in the water, that can be heard hundreds of miles away. So that's a pretty loud sound to travel all that distance.
Which we can't hear.
We can't hear it because we're not set up to hear sound underwater. But if you think about it, if you've ever been in the bath and stuck your ears in the water, you can hear sound. It just sounds different, doesn't it?
Yeah, it sounds.
And some sounds you can't hear because they don't travel so well.
Well, to me it would be on muffling.
Yeah, to be a bit muffling, yeah. But if your ears or whatever you use to hear your sound is set up to hear through water, then Bob's your uncle, it sounds amazing. Yeah? Mm-hmm. So what we're doing, ladies and gentlemen, is we're transferring the good vibrations coming out of Mr. Michael Carter via his lungs and vocal cords and lips. We're going to make those vibrations and we're going to catch them in the cup. Yes. And then the cup is going to then transfer those vibrations via the string to another cup, which is here, which is going to be the receiver. So what happens is the air is going to go in here when you speak. Speak into it, Michael.
Hello?
Hello. And the air is going to make, because the air is being pushed out, it's sending the vibrations out into the cup. And the cup, because it's got a flat surface here, that cup will vibrate very slightly. And those vibrations will travel down the string, which is solid, but it's still got lots of molecules inside, which will vibrate. So the string will vibrate with the sound you're making. And then when it gets to the other end, it's where the string's going to be attached, this flat bit will vibrate exactly the same as the way it's vibrating here. So that will move the air in the same way that that Mr. Carter is making it, and I will be able to hear those air movements in my ear, which will translate them into whatever Mr. Carter's telling me. Yes. Do you think this is possible, Mr. Carter?
Yes.
Yes. I'm glad you said that. Okay, because it'd be pretty pointless us doing it, wouldn't it? Mm-hmm. So shall we get on and do it?
Yeah.
Yeah, excellent. So we're going to start by making 2 tiny holes in the flat end of the cups, okay? And for that, the best thing to use is a pencil, which Mr. Carter is going to pass me now. Thanking you. Oh, got it. Good. So try and get it as central as you can. And you're just making a little hole, or quite a big one there. In my case, I'm going through cups here. There we go. So a little pinprick hole. So that's tiny. Yeah. Can you feel the air through it?
Oh. Yes.
Just yes.
I heard that.
You heard that air. There you go, ladies and gentlemen. He heard the air. Because you can hear blowing makes a sound. So then we're going to take a bit of string. So we've got a bit of string. And this is where I embarrass myself by spending ages threading the...
Hopefully we don't get it twisted.
Now I've finally managed to thread it. I'm not sure how long that took, but probably too long. We need to put a knot in this end as well and make sure the knot's on the inside of the cup, because you'll see for why in a minute, but the knots are very important. Yes. So, there we go. So we just need to, so if you can give me this hand, keep hold of the cup. So put it there. We'll do a little test. Twang. Excellent. Good. So that's that knot's holding. So we've built our cup and string telephone. This will also work with a number of other objects, but we'll talk about that later. So what we're going to do is we're going to test it. So what we've done Mr. Michael Carter here is going to be the receiver, and we've put a microphone in his cup, so to see whether we can hear it. Okay. Now, do you think it's going to work with me sat next to you, Michael?
No, because it would mean the sound won't be travelling.
It won't be travelling through the string, will it?
No.
It'll be travelling through the air, so you're more likely to hear it like this. So I need to move away from you, don't I?
Yes.
Okay, so if you just turn your head very gently and then lift the cup, be careful of the microphone, keep it a bit closer to you. Now I'm going to walk over the other side of the laboratoire, and you're going to see if you can hear it. Now remember, you need to try and listen to see whether you can hear it through the cup or whether you're hearing it through the air. Okay? So, this is going to be a bit tricky. Ready? I'm walking away. I'm walking away from you, baby. Right, I'm here. Hello. So here's my cup. But at the moment, we've got the string loose. So I'm going to talk very quietly in here. Are you picking anything up, Michael, down there? Can you hear anything? Is it clear?
Yes.
Can you tell what I'm saying yet?
Yes.
What am I saying? Michael Carter.
Okay.
Michael Carter. Michael Carter. What am I saying?
Yeah.
You can't hear it, can you?
No.
You can't hear it. Oh, hang on. I'm juggling my microphone. You can't hear it, can you?
No,
Because I'm speaking so quietly that the air that I'm pushing out of my mouth is not reaching you. So, but it's also... Keep your hands up there. Keep it off. So, it's also not travelling down the string. So how do you think we can make it travel down the string? What did I do to make the twang earlier? What did the string feel like? Did it feel floppy or did it feel tight?
It was all... You could tighten it.
We could tighten it. Excellent suggestion. Right, so keep tight hold. That's it. Keep tight hold. Yeah. Because it's got a microphone. So, ladies and gentlemen, I'm going to go and step off camera, and you should hopefully see the string tighten. Is that tight now?
Yes.
Okay. So I'm very gently, Michael. Now watch, ladies and gentlemen, for the direction. I'm going to do the same thing. I'm going to whisper into the cup, and we'll see if you can hear it.
Right.
You ready?
Michael Carter. Michael Carter.
Yes, I can hear that.
What am I saying? Michael Carter. Michael Carter likes apples. So what am I saying, Mr. Carter?
Hello.
Hello, what am I saying? Michael Carter.
I heard the word apple.
Excellent. Did you hear any other words?
Yes.
What did you hear?
I heard Michael Carter.
Excellent. Good.
So there we go, ladies and gentlemen. This is my normal voice. I don't know if we picked anything up on that on the microphone. But what is happening there, trust me, the science does work. You can make this any length, but the longer you make it, the more power you need to put in the voice to transfer the vibrations in the cup through the piece of cardboard onto the string. So there's no point me doing that while we're in the same room, because if I yell very loudly, you'd be able to hear me anyway, wouldn't you?
Yes. And I actually felt...
Yeah. So what we're going to do is I'm going to change the length of string. And I'm going to go and take the string outside, and you're going to see. I'm going to see if I can communicate from the outside to the inside. Do you think that'll be impressive, Mr. Carter? If I can manage that?
Yes.
Yes. The first challenge, of course, is going to be tying the string, because you've just seen, ladies and gentlemen, how long it's taken. So maybe we'll have a little intermission break while I do all the faffing with the string, and then we'll pick this back up once I've done all the faffing, rather than you watching me faff. And we're back. Excellent. So, Mr. Carter and I have now extended our telephone network. We're now going to attempt to try and repeat the experiment. And the frog's still here, Michael. We're going to attempt to repeat the experiment. And I am going to go into a different space, ladies and gentlemen. That's right. And Michael is going to see if I can hear him from a much longer distance where we can't actually see each other. So, unless I'm shouting, there would be no way you could hear me. Is that right, Michael? If I'm outside and I don't shout, would you be able to hear me?
And not a word.
Not a word. Excellent. Correct answer. Now then, so Mr. Carter again is going to be listening, and he's going to lift this up here.
Mm-hmm.
Now, actually, what we might need to do, ladies and gentlemen, is because this works better if it's the string's straight. So what we might do is, if you could stand up for me, Mr. Carter, keep hold of your telephonic things. I'm just going to move my chair out of the way, and your chair out of the way, so don't sit down. That would be comedy, but it's not that sort of show. We're doing serious science, ladies and gentlemen. You just start sideways to me. We're going to walk around the table. Keep going sideways and sideways and sideways. And then we're going to walk round here. We're going to walk round here, and you're going to walk forward until, keep going. Aha, right. So you're going to keep facing that way, okay? And we're going to lift the cup to our ear. Okay, excellent. There we go. That's a lovely profile shot we've got going on there. So, ladies and gentlemen. Oh, we've got string trapped around the finger. There we go. Thank you. So then I've got my phone here. You've got that one there. So I'm now going to start walking away from you. Okay?
Yes.
And we'll see how far I can get, and you can still hear me. So you keep listening, and you yell if you hear me saying anything. Well, don't yell, but just say, oh, I can hear you. Okay? All right, I'm not going to tell you what I'm going to say. Okay? So that everyone, when we're experimenting, everyone knows that I haven't told you what I'm going to say, so that you could just lie, even if you couldn't hear it, because we're scientists, aren't we? And what are scientists? Experts. That's right, ladies and gentlemen. You heard it here first. Right. Okay. So I'm going to go out the door, and I'm going to walk away, and you're going to be listening out, and you're not to snigger or laugh or say anything about me while I'm not looking, and you're going to listen out and tell me what you can hear. If you can hear anything, of course, because the experiments don't always work. That's the nature of science, ladies and gentlemen. Right, I'm off. Hello. Right, and I'm off out through here. Keep following, but don't stand on the cable. Right, get ready for it going tight, Michael. Oh, ladies and gentlemen, look at this. Look at this. Now then. So, if you just come in here, you can see how far away I am from Michael. There we go, can you see Michael? Ah, we're all the way over there. Right, okay, I'm going to now start talking to Michael. You can put it back on my lovely face now, thank you, hello. So I'm going to talk quite quietly, okay, so that Michael can't hear me. So hopefully, he will be able to hear me down here.
Michael Carter, can you hear me? Okay, Mr. Carter, I'm speaking to you live from outside the log cabin. I want you to tell Mark that he smells of poo. Are you going to tell him that?
Mark can smell the poo.
Yeah. Give me a thumbs up if you've told him. Excellent. Brilliant. So, ladies and gentlemen, I'm coming back in.
I'm coming back in. I'm coming back in, Mr. Carter. Can you hear me shouting?
Yes.
Excellent. So, ladies and gentlemen, that was amazing. I'm here, look. Woo, hello. Just take a step back so I can squeeze into shot. So, looking at the camera, which is that way, that's right. So, ladies and gentlemen, we've proved with 2 cups and some long length of string, I can speak to Michael Carter without shouting from right over there. And I don't need to shout, and you can hear me perfectly crystal clear on the cup, can't you?
Yeah. And I just, for any of the viewers, I don't know if you've seen that, but I pointed my fingers just to outside.
You pointed it outside because you could hear me, yeah? Excellent. And I wasn't being rude about Mark at all, was I?
No.
Okay, you don't have to answer that because I don't want you to lie, because I was being rude, wasn't I? Yes, okay, right. Okay, so we're going to get reset for our next experiment. Ooh, let's go. We're back, Michael, we're back. Excellent, so we've reset our laboratory of sound, our audio booth, our sonic temple of experimentation, and now we're going to try something different. So one of the problems people might have noticed, Michael, when we used the old string and cup method, is we had to be in a straight line, didn't we?
Yes.
And we had to keep it tight.
Yes.
Which would get a bit tiring if you got to speak for a long time.
And
And it wasn't probably as loud and as clear as you might be used to. Is that right? It was. You could hear it,
Yes.
but it probably wasn't as crystal clear. Just. yeah, you had to listen quite carefully. So now we were transmitting the sound through string. Now we're going to transmit it through tubes using air, which is how we normally hear, isn't it? So we're not having to change the sound from air to string. We're just going to use air, but we're going to have to make the air travel, because if you just shout, the air goes everywhere, doesn't it?
Yeah. And
So if I go outside and shout,
nowhere.
it just goes everywhere and everyone can hear it. But what if I want to say something private to you, that just me and you? What am I going to have to do? We're going to have to trap the air and direct the air to where we want it.
And yeah.
And we're going to use these, ladies and gentlemen. We're going to use these tubes. And look at these sexy handsets we've got here. There. For those who are old enough, this is what telephones used to look like.
What?
If you feel these, right, they're the old, U-shaped ones. So, Michael's going to stay in here in the nice and warm, because it's quite cold out there. So what we're going to do, ladies and gentlemen, is that so it's good. Just let me attach one. So we're going to attach these tubes. So hold that up to your ear.
Yeah.
And then we'll just test it that it works. Like this.
I can hear something.
Can you hear me?
Yes.
Excellent. So even though I'm next to you, is it quite loud when I'm whispering?
Yes.
Excellent, good. So, ladies and gentlemen, I can speak very quietly and he can hear me perfectly. But can we do it over a distance, Michael? You keep hold of your phone, don't you? You might need to keep quite tight because these are new tubes, so there'll be a bit of things. Okay. Right, so I'm going to take one of these. Oh, there we go. I'm going to put that on there. Now, so I'm going to ask my glamorous assistant, who's filming me over there, just to take that for a second. Keep filming me. I'll keep the camera on me. Hey, on me. Yeah, I'm the star. And then we're going to take some more tubes. Oh, that's a short one. I want a long one. There's a long one. We want some length, don't we, Michael?
Yes.
None of this messing about. Right. You might have to grip quite tightly because they're a bit springy, these tubes. Yeah. So we're just going to connect up these. Excellent. Right. Now then, if you let me have the rest of these. Now we're just going to go over here. Right then, Mark. I'm on this camera now, I believe. Right, so, keep tight hold. So look, ladies and gentlemen, we're not even going to attempt to try and keep this taut, because that would be virtually like a massive snake. It's got a mind of its own, ladies and gentlemen. Why didn't we rehearse this beforehand? Hey, this is live science, ladies and gentlemen. Yes, you're watching it in action. Is it going to work? That's what we want to know, isn't it, Michael? Right.
Yeah, hopefully if the line doesn't snap.
So, you can see, ladies and gentlemen, this is quite floppy. Yeah, right, where are we going to get to with this, Mark? Right, now, before, you remember, if you just turn around, Mark, if you look over there, that's where we were stood. And we had to have a more or less straight line to Mr. Carter. There we go. So, hang on, I need another one of those. But hopefully, with this one, look, I'm going round the corner. Going round the corner, ladies and gentlemen. I am. I'm going even further round the corner. So, I'm hoping that Mark and Mark inside, who's on the filming, Mark and Mr. Carter can't actually hear me. They probably can't hear what I'm saying now. I could be saying anything about them. Oh, hello. Lost control of me. Lost control of it. Bloody heck. Sprung back now then. Now, hopefully, we can have a conversation, right? Oh, it's going terribly well. Right, come over here.
Okay.
Right, if I hook that round there, then it's not going to keep pinging off. Right, okay, come closer, come closer.
Okay.
Right, Mr. Carter, can you hear me?
I can now.
Excellent. Do you know where I am?
Outside?
I am outside and I can hear you perfectly. So what's happening here, ladies and gentlemen, is that I'm forcing air into the tube, and the tube is forcing the air that's vibrating by my voice down the tube and all the way down the tube and directing it into Mr. Michael Carter's ear hole, which is where he hears from.
Well, it was till the line snapped.
Oh, have we got a line breakage? I can still hear you.
No, now.
Yeah,
Mark had to fix it.
Oh, did Mark have to fix it? So as soon as you break the line, that's a very important point. If the line breaks, then all the sound, the air that's transferring the sound, the vibrations, is actually lost, isn't it? So you can't actually hear.
Yeah.
Now, am I quite loud or am I quite quiet?
Just at normal volume.
Normal. Right, what I would like you to do, Mr. Michael Carter, is I would like you to move the phone a little bit away from your ear, because I'm going to show what happens when you increase the amount of energy you put into the vibrations. Okay, and you're going to stand by and tell me what happens when I increase the amount of air that I'm vibrating down this tube. Okay, but don't hold it right to your ear, hold it a little bit away. Okay?
It's starting to get louder.
I can feel it coming through the air tonight.
It's starting to get louder.
Oh Lord, I can feel it coming through the air tonight, or in this case, a tube. Now then, Mr. Carter, I'm speaking at normal volume. What happened then when I started singing quite loudly? Did it get louder or quieter?
I heard the volume increase.
You heard the volume increase. That's right, ladies and gentlemen. So the more energy, the more power I put in, the bigger vibrations I make, the more energy to make the air shake like that, the louder it will be that you hear it. So I'm going to go back inside now, and we'll get set up for the next experiment.
Yes.
Okay, ladies and gentlemen, so we've done our first 2 experiments exploring the world of sound.
Yes.
So that's it from me and him for a minute. In a minute there will be 2 more of us. One of them might look a bit like me. Hello, I'm Mike and this is Mike. So we're joined by another Mike, because we previously had, for the first set of experiments, another Mike. Now this Mike has problems with his hearing. So you say, what's somebody with hearing problems doing exploring sound? Well, you may remember that with the other Mike couldn't see, but he relied a lot on his hearing. So what we can do today is we can visualize what sound looks like. Now, if you remember, we were explaining sound is all about good vibrations. So I can, through the wonders of science and with my able assistant, Mr. Michael Aitken, we can make sound turn into visual patterns. We're going to be looking at this here. What? Yeah. So this is a plate, and underneath it is an everyday speaker that looks a bit like this one, but we've put a plate on it. Okay? And then what we're going to do, we're going to use this bit of kit. Michael, can you pan up to there? And this here, this is going to make the sound, which is going to go through the amplifier and then through the speaker, and this plate is going to show us what that sound looks like. So Michael might not be able to hear it, but he will be able to see it. So we had a small technical fault, didn't we? Yeah. So we're going to be watching this. Okay. So I'm going to now the sound, and then you are going to look. So let's see what happens when I turn the sound up, ladies and gentlemen. Or maybe not. So you can see, look, it's made a heart. So Michael, so you see how it's made a shape? And it's vibrated out. So that's the sound making the vibrations, and it's spreading it out into a pattern. So Michael, can you get some of this and sprinkle around the edges? Yeah? You do that?
Yeah.
So a bit more. So we put a little bit more on. So let's see when I put the sound on. So I can hear the sound. So you see how it's creating a little pattern, a shape. Now each different sound will make a different shape because it's a different pattern of vibrations, and we can show that because up here I can change it. So let's see what happens when I change it. Oh hello, I could if this hadn't gone off. There we go. So you can see there, look. So different sound, different shape, and different pattern. Yeah? And I can change it again. So you can see as I'm changing it, that's quite good. Once you've got the little holes in this one here, can you see that? Yeah. So that's really good. So that's a really good visual demonstration of what the vibrations are doing. So if you remember, I said that sound is molecules, bits of stuff in the air or in wood or whatever, shaking together and causing a ripple effect. And you can really see that in this experiment. You can really see the vibrations being transmitted. So we'll just stop that there. No, that way. And now we're going to look at, when you're playing your speakers at home, we're actually going to look at what happens with your speaker. So we were saying how your speakers at home might work. So if you watch the cone, this is called the cone, when I put a sound through it, watch what happens to the cone. So can you see that? You see it? So that's doing exactly the same as what we were doing with the paper cup and string. The string's passing the vibrations through and then making the base of the cup rattle. So what's happening here is that the amplifier and the sound generator are making that cone vibrate very fast to make all the different sounds. And we can see this in quite a spectacular way. So if you just relax a little bit there, Michael, we're going to get something in called a non-Newtonian fluid, ladies and gentlemen. But basically, it does some weird stuff. So if you have a look in there, Mike. Yep. So if you have a look in there, close up, extreme close up. So this is a mixture of corn flour and water. Okay. And I'm just going to make sure that it's loose enough to go in. So you can see that's a liquid, but it does some strange stuff. So I'm just going to put a little bit into the speaker. Now don't do this at home, children. Only in the lab. Only in the lab. Right, here we go then. So let's get some of this in. So you can see I'm just pouring some of this non-Newtonian liquid, also known as a thick cornstarch thing. Now, so let's have a close-up on that, Mike. So now, what happens when we put sound? So what happens when we put sound through that? What are we going to see? What? You think it's going to splash everywhere? Oh, right. So Michael thinks it's just going to go everywhere. Then I'm just going to create a mess, which is, after all, what I am famous for. So let's have a little look. We'll start mid-range. So we're going to start with the sound right in the middle. Let's see what happens. Anything happening? Nothing yet, ladies and gentlemen. Oh, we're not getting very much on that. There we go. Look at that. Can you see that, Michael? Can you get right in there? You see the pattern it's making on there? Get right in. Right in. Can you see the pattern? It's okay. Can you see the pattern it's made? Yeah? So it's making... So different sounds, it's making different patterns. Tends to work better at the lower frequency. Oh, look at that one. So you can see by changing the sound, we can make different types of shapes in this liquid. So Michael, if you give me your hand, Can you feel that?
Oh.
Yeah. So. So as I'm changing the sound, that's quite a good one, isn't it? Yeah? Good, excellent. Okay, so we've made a slight adaptation to the setup, but it's exactly the same. We're just using a bit of foil to stop it sticking to the cone, because that's why we were getting. Well, you'll see why what we thought was going to happen when we do this. So we're just going to start with a mid-range sound. Let's see what happens as we get louder. And now. See that doing weird. Way! So you can see it's making loads of weird shapes. Oh, that's quite a good one. So, we're now doing three-dimensional sculpture with sound, ladies and gentlemen, and that's why we were using a non-Newtonian liquid. Because if we put a normal liquid in there, it would act very differently. Let's see what happens. And then you see. And then, so it's now gone all runny and bubbly again. Now let's see what happens when we go lower. And as we go back higher, it turns back to a liquid. So the vibration, when because of the way Newtonian liquids work. Oh, hang on, we've got a bit of a spillage. Because of the way it works, the lower the vibration, the Newtonian liquid acts differently to when we've got a higher level of vibration. So when the higher frequency, it's more like a regular liquid. The lower the frequency, it starts acting a bit more like a solid. There we go. Find the right frequency. So you can see there it's acting a bit more like a... Is that enough nonsense? Way! 80. That's about 72. What? 84. So there you can see we're about 84, so that's reasonably low, but you can see it's doing all sorts of strange things. So the vibrations are causing the Newtonian liquid to react, so all the molecules inside it are bumping in different ways to create these weird and wonderful patterns. So ladies and gentlemen, you can see that we can make sound a visual thing. So as well as hearing it, we can see sound and we can feel the sound, we can feel the vibrations. Michael was listening to it through his fingers. So we can hear through our fingers, we can hear through our ears, and we can see it through our eyes. So that's really good. So sound's more than you think it is. It's much more of a multi-sensory thing than you think.